Welcome to my science class. In this class, we'll solve sums from class 10 NCERT textbook. The sum is an electric lamp whose resistance is 20 ohms and a conductor of 4 ohms resistance are connected to a 6-volt battery. So given the circuit diagram also given. Calculate the three questions in this. Calculate first one, the total resistance of the circuit. Next, the current through the circuit. Third, the potential difference across the bulb and the conductor. So they are given as the circuit diagram. So here there are two resistances, R1 the bulb, R2 the conductor. It is 20 ohms, this is 4 ohms, and there is a battery of 6 volts battery. It's a 6 volts battery. So since they are connected in series, the current will be constant throughout the circuit. Current is constant. Then total the potential difference of the circuit will be equal to V1 plus V2. What is V1? That is the potential difference of the bulb. V2 is the potential difference of the conductor. If we add them, we'll get the total potential difference across the circuit. Then the total resistance of the circuit Rs will be equal to the sum of the resistances R1 plus R2. R1 plus R2 will get the total resistance. So now we'll answer the first part. So the total resistance of the circuit will be Rs will be equal to R1 plus R2. That will be equal to, what is R1? 20 ohms. What is R2? 4 ohms. The total resistance will be 24 ohms. The first part has been answered. Next, we have to calculate the current through the circuit. So now we have to apply the Ohm's law, the whole circuit. So part the question B. Applying Ohm's law to the circuit. Because the current is constant throughout the circuit. So the Ohm's law says R is equal to V by I. That is Rs, total resistance. So here Rs is, we just found out now the Rs, the total resistance is 20 ohms, 24 ohms. The total total value we have is 6 volts battery, because the battery is of 6 volts. 6 by the current throughout the circuit, we have to calculate. So if you cross multiply, 24I will be equal to 6. I is equal to 6 by 24. So I is equal to 0.25 amps. This is the current through the circuit. So the part 3 of the question, we have to calculate the potential difference across the electric lamp and the conductor. So we have to apply the Ohm's law across the lamp separately and across the conductor separately, and find out the calculate the value of V. Applying the Ohm's law across the lamp. Ohm's law to the lamp. So here R1 will be equal to V1 by I. I is constant. So what is R1? R1 is 20. Calculate the V1. I we already calculated, that is 0.25. So here cross multiply, V1 is equal to 20 into 0.25. So V1 is equal to 5 volts. Therefore, the potential difference across the lamp, the potential difference across the lamp is 5 volts. Now we will apply the Ohm's law to the conductor. Applying Ohm's law to the conductor. So R2 is equal to V2 by I. So R2 is 4 ohms, V2 divided by 0.25. So V2 is equal to 4 into 0.25. So V2 is equal to 1 volts. Therefore, the potential difference across the conductor is 1 volt. Please like, share and subscribe. Thank you.